So we have two parallel lines. Which lines would be parallel in that diagram? Nick?
The ones that say A and B.
Good, the ones that are labeled A and B. So we have two parallel lines, and they're cut by a transversal. And that transversal is labeled T here. So that might be a new word for us. A transversal is a line that intersects two or more lines at different points. Alright, so like I said, that line T here is what we call a transversal. It's going to hit, in this case, two lines. And it hits them at different points. You may see the same type of diagram drawn differently. So if you have two parallel lines, the transversal could go that direction. It might even just go straight through the parallel lines. But no matter which direction or which way your transversal is going, as long as you have the parallel lines, these definitions that we talk about at the bottom, the relationship is always the same. Okay, so it works for however the diagram is drawn. Just with the two parallel lines, a transversal going through it. Can anyone make any observations about the diagram up there? Anything you notice or observe before we start writing anything down? Someone mentioned we have a lot of angles up there, right? A lot of numbers. 1, 2, 3, 4, 5, 6, 7, 8. All those angles are created by this drawing. Anything else that stands out to you? Yeah.
Letters
Okay, so the smaller lowercase letters here are those are there to label the line. A, B, and T kind of tell us which line we're talking about. What about this interior, exterior? Were you wondering about that? Interior, that tells us that it would be anything inside the parallel lines. That's going to be useful down here at the bottom when we're talking about the different relationship, the types of angles that are formed. So interior means anything inside the parallel lines, and then exterior are outside the parallel lines, up above or below. What angles fall in the interior then? Miss Bella?
3, 4, 5, 6.
Good. 3, 4, 5, 6. And then the angles that are on the exterior. Kaylee? 1, 2, 7, and 8. Okay, so that'll be useful down here as we go. All right, first one we're going to talk about are called corresponding angles. And these are located in the same location on the same side of the transversal. If we draw a picture, that'll kind of help describe what this means here. So I'm going to copy that same diagram from up above, our two parallel lines cut by our transversal. So they're in the same location on the same side of the transversal. So an example, I'm just going to highlight one example there. Those two angles would be corresponding angles. So they're both in like that same location. If I was just looking at this line, this is in the top right. And then if I just had this line to look at, this is also in that top right location. I also like to think about it, if I were to slide the two parallel lines together, these two would match up. They're corresponding in the same location. So from this diagram, 2 and 6 are what we would call corresponding. And remember, we can write angle 2 with that little symbol in front. So angle 2 and angle 6. That would be one pair. Does anyone else see a pair that would be corresponding? So they're in the same location. If we slide the two parallel lines together, they are going to match up. Lillian?
3 and 7.
Good. 3 and 7. These two down here. They're in the same location. They would match up. Anyone see another set? Drake?
Angle 1 is 1 and 5.
Good. 1 and 5. Yep. And then there is one more pair. Joe?
4 and 8.
Good. 4 and 8. Now, if you were just looking at 2 and 6, and I mentioned too that we could slide them together and they would match up. Does it look like they would match up exactly? Are they going to be the same measurement? 2 and 6. We're going to be doing some maneuvering with some angles tomorrow just so you can double check this. But yes, they would. They're going to be the exact same measurement, and those angles are what we call congruent. So a fact about them is that they're congruent angles. They would be the exact same measurement. All right, next type, alternate interior. And the names here start to make it easy to identify. You can kind of use alternate. We could think of the word opposite. And then interior, we talked about them being on the inside of the parallel lines. So these are going to be located on opposite sides of the transversal. And inside the parallel lines. And we'll make that diagram again. And if I highlight, so they're on opposite sides of the transversal, but inside the parallel lines on that interior. So I could say these two angles here would be alternate interior. Opposite sides of the transversal on the interior. All right, so from up above, those would match with 3 and 6, for example. 3 and 6 would be a set. And Leah, you got another pair that would be alternate interior? Oh, you have a question. What's that? Oh, inside the parallel lines, sorry. All right, so 3 and 6 are a pair. What's another pair that would be alternate interior? Got it, Leah? Which ones? Okay, now 4 is on the interior, but 1, do you see how 1 falls on the exterior? Okay, so you're right about it being the alternate, but we need another interior. There you go. So we are still going to use 4, but 5 would be the other one it would be alternate interior. So they both have to be inside, and they're on different sides of the transversal. Yes, Angelina.
7 and 2.
All right, now 7 and 2 are going to fall in the next one, because notice those are they interior? Those are going to fall in our exterior. Okay. They are on that. They alternate, or the alternate, but they're not on the inside. All right, these also would match up exactly. 3 and 6. Notice those are both obtuse angles, and if I were to rotate it around, those angles would match up and be congruent. Exactly the same measure. All right, this one is very similar to the one up above, except now it's alternate exterior, so on outside of the parallel lines. So again, it's going to be located on opposite sides of the transversal. Oops, I needed on opposite sides of the transversal. But now we're exterior, so they are outside of the parallel lines. All right, so draw your example again, and then we'll highlight Angelina had mentioned 1, 2, and 7. So those fell on the exterior, and they are alternate exterior. So that would be 2 and 7 right there. All right, what would be our other pair? There's one more set. Kaylee? Good, 1 and 8. So just the other pair here. They fall on the exterior, and they're on different sides of that transversal. All right, do those look like they would match up and be the exact same measure? If you just look at 2 and 7, do they look like they'd be the same? I know it's kind of hard to see if you were to turn it around and match them up. Those are also going to be congruent. So they are also the exact same measure. Whatever angle 2 is, angle 7 is the same. All right, and then our last type, consecutive interior angles. And consecutive kind of means one right after the other. So in this case, they're going to be on that same side, one right after the other, interior, on the inside of the parallel lines. So they're located, whoops, I got a pen here. located again, or located this time on the same side of the transversal. And because it has that word interior, they're going to be inside the parallel lines. We'll draw the diagram one more time and then highlight one sample. Of the consecutive interior angles. So those have to be on the same side of the transversal together and on the inside. So that would be an example there. So like from our diagram up above, 3 and 5 would be a pair. Angle 3 and angle 5. And then there's one more set of consecutive interior. Drake? Good. Angle 4 and angle 6. Now, looking at angle 4 and angle 6, do those look like they would be congruent? They look like they would match up? No. In fact, 4 is more of a acute, right? Less than 90, whereas 6 is going to be an obtuse angle, greater than 90. These types of angles have a different relationship. We say that they are supplementary. Have you guys heard that word before? I'm learning that maybe you guys didn't get to that last year, but supplementary angles are any two angles that add up to 180. So these consecutive interior angles together add to 180 degrees.